Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Now, in today's video, I thought it might be helpful for everyone if we do a review of where we are with the Tiny Basic Computers /ProjectRio self-build computer project. About 3 years ago, in fact over 3 years ago, September 2020, I launched a brand new project here on the channel called Tiny Basic Computers. The plan was very simple. We were going to build our own self-contained real 8-bit programmable computers using modern AVR Arduino chips, and that's exactly what we did for a whole series. I then followed up Tiny Basic Computers with a more advanced system still based on Arduino AVR called ProjectRio, which added things like HDMI color out, USB keyboard support, and more memory, SD card, that kind of thing. And again, it was hugely successful. In fact, the Tiny Basic Computers original project actually went on to be licensed and was used by a private education firm called Gocart UK under the banner Make and Break Computers, and also here in the UK by the National Museum of Computing, who used a version of it for their STEM and outreach school project work and group activities. So far, I haven't sold a version of this product, but a sister version has been on the market for a little while from my friend and colleague over in Brisbane, Australia, Scott Julian, and his AlphaWorks brand, which has released a similar build version using the same source pool that we've been using for ProjectRio and Tiny Basic Computers. Now, since the end of last year, that's 2023, we took a pause on the ProjectRio build. So in this video, I'm going to take you through some of the development work and prototypes, both for Tiny Basic Computers and ProjectRio. So let me share with you one of the first new prototypes I've been working on. Now, this one is a little bit different as it sort of reverts back to our original Tiny Basic Computers black and white builds. That was the version 3 and version 4X. I have it here. It's in a little bit of a different setup and configuration to what we've been used to. And yes, it is being held together with blue tack and hope. Let me just bring it up on your camera so I can show you in a bit more detail. So here it is. It's using the same Arduino Nano and standalone Atmega 328P graphics chip as we've seen before. So there's actually two Atmega 328P 8-bit AVR chips that run the system. It's very similar to the breadboard builds that we've done for Tiny Basic Computers, and it outputs the same composite black and white low resolution PAL or NTSC. It does have a few additional features such as the ability to run off a 9-volt battery, the mounting of a USB socket. I say mounting, I mean blue tacking of a USB socket on the front, and we have a couple of onboard LEDs that are actually controllable, as well as sound and buzzer, and we also have an on-off switch here on the back, as well as a better onboard composite socket as opposed to trying to wire something together yourself. There was a loose fly cable that we used in previous builds. So the main premise for this as a design was my attempt at the possibility of doing a retail kit version of one of the computer products that we design and build here on the channel. Again, I stress, up to this point, I have not released any kind of commercial product, and that makes ProjectRio Tiny Basic Computers different to the other computer build projects, and there's many of them. My project, I've never sold anything, so for those who join our Patreon at patreon.com/Wi-Fi Sheep and join the general downloads or the ProjectRio tier, in exchange for your support for my video content, I give you a gift, which is the source code for whichever project you are interested in. So you're not buying ProjectRio or Tiny Basic Computers directly from me, and I'm not selling directly to you. If you want a completely free version, we also support a free version over on the ever-growing Tiny Basic Computers ProjectRio Facebook group, which you can see by going to facebook.com/WFS Tiny Basic. Anyway, here is the setup, now set up and powered. So I've got a 9-volt battery attached, and I'm just going composite into a upscaler, HDMI out, so you can see what's on screen. I just need to add a PS2 compatible USB keyboard. The tiny basic machines are not capable of driving a USB keyboard. So although it's USB socket, USB keyboard, it's actually using the older PS2 standard. So it's really important to make sure that your USB keyboard does have the protocol drivers to run as a PS2 device. Otherwise, this won't work. A good example would be Apple devices that just do not work with this particular system. Anyway, let's power up, and we can do that just by flicking the power switch. The power light now comes on. There's the boot kernel, and there is the prompt that we get on the screen. So what's interesting about this is, although it's using the Atmega 328P, which was the earlier, smaller 2K of RAM chip that we used and built the original system around, I've actually ported ProjectRio's kernel over. So it's actually running as a version 5.7.2C, which is actually the newer ProjectRio color kernel. Not really designed or originally compiled to run on the Atmega 328P. Instead, meant to be running on the Atmega 2560 as used in the Arduino Mega chips that we based ProjectRio around. Saying that, they're all AVR, they're all 8-bit, so technically the code is all backwards compatible. You just have to make sure that you map the memory correctly. Because this is now running as an experimental version 5, it is technically ProjectRio. So I should be able to ask for memory if I get the right key. Shift 3, hashtag mem, and there is the memory system. Again, I remind you, the hashtag systems are only currently on the current builds of ProjectRio, or version 5X or newer. So version 4 for tiny basic computers, or version 3, which is what the free version that we have on Facebook uses, doesn't use the hashtag system, so it's just mem would work on those systems. But because I said this is technically the ProjectRio kernel, we actually have access to all the ProjectRio commands, including things like I can say fcol4, and that would actually give you a color command. It sends a escape code, which obviously this kernel can't use or see, so it just passes. But all the color codes and all the draw statements are actually included in this version of the kernel. One thing that now does work, and this is new and why I've been experimenting, is for the very first time on an earlier nano build of the systems that's using the Atmega 328P, I can actually ask CLS, and I can now clear the screen, which might seem trivial, but no other earlier version has been able to do that. So all the version 3 and 4X kernels can't actually clear the screen, so you are constantly stuck with a scrolling text pattern that you can't clear the screen. You have to sort of do many carriage returns to try and wipe the screen clear, and it never quite works, but now you actually can. The way that works is it actually sends an additional data line. So it literally pulls a line high and low, and that's attached between the Atmega 328P on the chip, acting as the video terminal, and the main nano board on the front, which is running the basic kernel. It pulls it high for a few seconds, the chip detects it, it goes, that pin is high, that means clear the screen, and then it drops back low again. If it's low, it doesn't. If it's high, it does. So instead of sending instructions over the UART serial between the two, it actually pulls an additional pin, so there's an additional wire, which has to go high and low, and that is what clears the screen. As I mentioned, this twin board approach, despite still being limited, might be something that could turn into some sort of purchasable kit. I'm just really conscious about all of this, is it's really about giving people reference designs so they can actually go and build their own systems, sourcing parts locally to them or online at their own native currencies, which is going to be far cheaper than me purchasing things, having to then ship them here, package them, put an extra 20-30% on, and shipping, tax, etc., and then ship to you. That was always the problem, and that's also why here on ProjectRio Tiny Basic Computers Wi-Fi Sheep, we're doing things a little bit differently, and that's why we're very much the underdog. We're not going to compete with the likes of Commander X16 or I think it's the Argon or Argon Lite or whatever it's called. We're not going to compete with those boards. They're actually products that have either got a lot of money, a lot of momentum behind them. We're very much the underdog, but we're building these computers for fun. Which brings me on to another point just quickly, is about critical mass of users and software ecosystem. Well, there isn't one. And it probably isn't going to be one. I don't have the time to do it. The community is very small here, but it's more about you building a real computer and having the enjoyment about experience with electronics and getting something to work, and maybe writing a little bit of basic code and just basically having fun with building simple computing systems. And that's really what both these projects are about, rather than trying to kind of sell you things and make, commercial money out of things, which, to be honest with you, I don't think I'd make much, if anything. I think it would be a loss leader, and I personally, being a one-man operation, don't really have the time. So I honestly think this is a far better way of proceeding with this project. So moving on a little bit to a prototype machine that many of you might be a little bit more familiar with, and here it is. This is the ProjectRio prototype. Technically it's prototype 2, although we call it prototype 1 because what happened was we started with the innards in a different case, and then we switched out to this, which is a modified off-the-shelf Chinese PC ITX case, which actually is generally suitable for our needs. And we actually spray painted, well, I spray painted the yellow and the textured finish on the front, just to sort of make it look a little bit different from a bog standard PC case. Let's have a look inside then. So really nice case, and actually these weren't too expensive. It actually cost more to get them shipped, and inside was the beginnings of this first prototype. Now, because at the time we were building this, there were still supply issues because of the pandemic, I couldn't get hold of Raspberry Pi Zeros, which I wanted to use as the video terminal. ProjectRio was different because it actually used a larger board. So this is an Arduino Mega with a custom shield fitted on top, and it outputted to a Raspberry Pi, which ran as a dumb terminal using a special bare metal operating system called PiGFX. No Linux kernel, instant booting. It literally worked as a dumb terminal, waiting and receiving signals from the UART serial line, allowing us to connect these two together. Now, this system has been offline for a little while, but hopefully it might still work if we're in luck. Admittedly, it probably has come to the end of its life as we're ready to build a new ProjectRio prototype, but this has been a very useful development machine up to now. Admittedly, it is beginning to slightly fall apart. The advantage of having a Raspberry Pi was that we could actually have HDMI as well as composite sound and video. We also, for the first time, could actually use native USB, although admittedly the socket's loose. So we could use native USB for keyboards as opposed to requiring the PS2 driver as before. And also, something I'll come to in a moment, for the very first time we actually supported direct DB9 sockets, including originally wired Atari 2600 paddles and joysticks, or modern clones, would now be compatible with our system. So I've just tapped the HDMI in that we were using previously with the converter box. I'm going straight through the capture card, so you should be able to see it. We're going to use a Raspberry Pi 2 type power supply, and we'll go off the mains with that. And that plugs in here. Again, everything's become rather loose on this prototype, so it is probably at the end of its useful service life for us. And finally, we'll add the keyboard. Now, as well as the USB socket on here, we took full advantage of this original Raspberry Pi, which is in here, where it had the original USB out desoldered and the internal pins used for the USB that comes supplied with the case actually added. So we split it into two. So we've got one active here, hence the blanking plate, and we have one active on the back. So it means we should be able to just put the keyboard in like so. Now, if we power up, the board lights up. There we go. ProjectRio takes a little bit longer to boot up than its previous incarnations. We'll also see that the power light has come on, and this, if we press, actually acts as a reset. It will actually reset the system. And here we see ProjectRio Mega Color and version 5.7.1. So it's actually almost identical kernel to what I showed you running previously, but this of course is designed to run in color thanks to PiGFX running on the Raspberry Pi. and we also have a lot more memory. So in this case, we have just shy of 6K of RAM available. And the EEPROM, which is the other advantage of the Atmega systems, is they have onboard EEPROMs for saving of data. We actually have 4K of EEPROM, so we can actually do a hashtag mem. And we've got, there's actually a program in memory, so let's just have a quick look what that is, because I don't honestly remember. So we go load. We can list the program. Ah, I know what that is. And also things like CLS also works. And I can type buy. And it'll just reset the system from a command. We also have access to colour, so I can go foreground colour 4, which is blue, so you can't see it. Let's go foreground colour 6, so you can see it. Delete keys work on this as well. We can also say background col 20, so it's blue on blue, CLS, and that changes the whole colour. I could have picked better colours, couldn't I? So example, I could go 0, which is black, CLS, oops, CLS, there we go. So it's that easy to change the colour system, and although some people have been rather unhappy about my use of Raspberry Pi in this build in any kind of capacity, it does work very well. Plus it gives us the advantage, if we want it, of having a full HDMI out, as well as composite video out, which can be set to NTSC or PAL, whilst retaining all the 8-bit functions of the Arduino AVR architecture. Something else I want to share with you, which is new for ProjectRio and will shortly be coming up for those of you that are building along with your own ProjectRio systems as part of the video series, is the use and now support of Atari 2600 style DB9 joystick interfaces. And here I have a modern clone of an Atari 2600 joystick. Now, to stress, these have to be compatible with the original Atari 2600 hardware and have the original DB9 style plug on the end. So modern USB remakes of these, such as those included, for example, on the Atari 400 mini system, are not compatible and don't work. However, if you can get yourself either an original or a Chinese remake one like this is perfectly acceptable, then these will now work with ProjectRio. During a live stream, what we did is we actually added a DB9 socket onto the back of the case. This would normally be used for VGA, which uses a very similar connector, but we're actually using it for joystick, and we can actually plug in a DB9 connector. This now gives us the 4-way options on the joystick. Let me turn that the right way around. So we get 4 up, down, left, right, and we also get the fire option, which the processor, the Arduino, is able to read and process. If we go back to our system, which has been running quite well, let's just do a quick reset for you. And the system will reboot, so just give it a moment. There we go. We'll ignore the SD card error at the moment. It's because there isn't an SD card in the machine. However, let me just show you, if I go hashtag mem, you can see that on the user byte, so that's the available space on the EEPROM. There's 4K on EEPROM, but as you can see, there's 1,596 bytes available, which means there is a program in the EEPROM of the system. The EEPROM is on-chip memory. It's separate to external SD card memory, and it's something kind of unique that we can use with the AVR Arduino architecture. Now, to load that in, I can go load and list. And there is a tiny basic program, which, if we now run, gives you this interface, which is a prototype for Rio OS. Yes, so one of the ideas for this whole project was it now possible to create a kind of graphical user click and point interface for our homemade custom computers? And thanks to the power of the ProjectRio system and using PiGFX and a Raspberry Pi just as a terminal and video driver card, yes, it is actually possible. And this is where our Atari joysticks come in to be used as pointing and interface devices. Now, a word of warning, this is really flickery. All the graphics you can see on the screen have been written from basic commands using the PiGFX driver. So there's no external sources at the moment or bitmaps. It's all being driven from vector graphics or block color graphics. Again, I stress this is extremely flickery, and hence why this has not been shown publicly too much, and I've not released it to anybody as yet because it's basically not good enough. It needs some work. So if you are photosensitive, I strongly recommend you either slow this footage down. You can do that on the YouTube menu in the video, where you can actually slow the video down, or you can skip this part and I'll tell you when it's safe to look back. If you're okay with some very flickery images, then let me continue. And again, I apologize, this is a strain on the eyes. So using the joystick back and forth, I can move the cursor around. Every time I move, it has to redraw. The redraw at the moment is very slow, hence the flicker. That's why it flickers on every move. I do, however, have some buttons I can press. So I can bring the cursor over to System Info, and if I hit fire, I can now bring up dialogues and it can give me some information. So this build was December 2023. There is the kernel version. It reads the kernel from the actual Tiny Basic that we upload itself. And obviously there's me, and this was done late last year. I can now click OK. It removes the window. I know this seems really simple stuff that we're used to now with almost 40 years of graphical user windowing systems, but you have to remember this is running basically from scratch on a home-built machine written in Tiny Basic. We would normally have a series of demos. These would actually load off SD card. I don't have the SD card in the system at the moment, so these are actually going to fail. There you go, SD card error, fail, and then it crashes out. But it does show you the premise of basically a click and point interface. Now what I would really like to do, and by the way, it's okay, you can look back now. I'm going to stop moving the cursor around. I need to improve the cursor so that it doesn't have to redraw the screen on every move, because the system is not fast enough to do the redraw, as you've seen. But what I'd really like to do is incorporate commands into what will become Rio Basic, into the kernel. So instead of you having to use multiple lines to draw windows and dialogues, you can call them up just from the kernel, which means if you write your own programs for, if you like, Rio OS, you can actually just have this menuing system and point and click icons and buttons, but you can just bring up in your programs, as they'll already be there preloaded for you in the kernel, and you can call them by single keywords and then a number parameter. So that would save a lot of space and memory for your code. As I said previously, this build has probably come to the end of its life as a machine. I mean, I'll keep it together for now because it's an interesting footnote in development, but I am ready now to build a better machine because I want to swap out some components, including ditching the original Raspberry Pis. The reason we used these originals was because these are the only boards I could get hold of that I could break apart that were cheap enough during the pandemic and the lockdown and the chip shortage. What I actually want to jump to, and I just got a used one here, is I want to jump to Raspberry Pi Zeros. They're smaller, they're relatively cheaper, and actually for power consumption, they're far more reliable. Part of the problem with running with original Raspberry Pis is that they're just not very good at managing power. They're very sensitive to power interrupts. They don't like, even if you hang a heavy keyboard like this keyboard just off camera, which lights up, if I try to hang this off that, it would just consume too much power. It would cause stability issues and cause the terminal to crash. And we have had it where this side of the system has failed, despite the fact that your 8-bit side is still running fine. You have to remember, in a Tiny Basic system, these two sides are running as two standalone computer systems communicating to each other via a single UART serial, so RX to TX via a level shifter, because of the 5-volt logic here and the 3.3 TTL logic here. This is all stuff we have covered in some detail during the live stream evenings on 8 till late. Okay, so next I want to share with you an idea for a possible future ProjectRio that I don't think I'm going to go with. So when I first announced ProjectRio, which was actually working as Tiny Basic computers for colour, so it was the later 4X series that began using Raspberry Pi as the video terminal. And a lot of people went up in arms, some even over dramatically stating to me that the project was dead to them and they were no longer interested just because I was using cheap and readily available Raspberry Pis as a video terminal. And I really don't get what the problem is. But anyway, so I have been looking at alternatives to Raspberry Pi to drive the video. And one of those is an absolutely fantastic library called FabGL, which is for the ESP32 microcontroller series. If you're not familiar with ESP32, we have covered it here on the channel before. It's an alternative to the Arduino AVI platform, created by a company in China called Expressive Systems. The ESP32 architecture is actually a dual-core 32-bit custom chipset. Luckily, the tiny basic kernel that we still use for ProjectRio actually compiles and will run on ESP32. And if you are a ProjectRio subscriber on our Patreon, it's patreon.com/Wi-Fi Sheep, there is a build of tiny basic for color, especially for the ESP32, so you can try it out for yourself. Now, the FabGL library has a number of things, including a custom color terminal, again to run on the ESP32. So I thought, was it now possible using ESP32 architecture to run both a version of Rio Basic or Tiny Basic for color and the FabGL video terminal all on one chip and one board? To test this out, I went and bought one of these off-the-shelf boards. Now this is from Olimex, who ironically actually also make the Neo 6502 single board computer, and they also make the, I think it's Argon or Aragon 2 Lite computer, which is Z80 based, which some are saying are competitors and rivals to what we're doing here. I disagree. I think it's a different product. They're trying to sell you things. I'm not, as I keep saying. But I thought, was it possible to take one of their products, in this case it's the ESP32 single board computer for FabGL, could we take this product, which wasn't that expensive, it's less than £20 or under $40 US, and actually focus ProjectRio to run on this off-the-shelf hardware. If I show you the board inside, it's quite a simple but elegant board. And here it is. The SD card, by the way, I was using to test. It doesn't need an SD card to work, so we could actually take that out. And you can see it's actually VGA based with PS2 for both keyboard and mouse. The ESP32 module is this module here, and you have, as I've already said, you have micro SD out, and you have some pin header for I/O in and out. So on the face of it, it's quite a nice board. Now, in order to get this board to work, so you can see it, I have got a VGA to HDMI adapter. It's not HDMI or composite compatible, so we do lose some functionality. It also can't run USB keyboard, so you're back to the same issue that we had with the original Tiny Basic Computers Series 3X and 4X systems. Okay, so we're set up and ready to go. One of the major disadvantages of this board, as you can already see, is just the amount of adapters you need just to get a USB keyboard in via a USB keyboard that has the PS2 protocols. It won't work with one, it's just plain USB, even with the adapter. And also the HDMI adapter for VGA to HDMI that also needs its own power supply, and it just about works and fits. If we cut to the video feed, I'll show you what's booted up. So here it is. This is an experimental build of Tiny Basic Computers. It's version 4.5.1 ESP experimental, so it says ProjectRio 2. It's strictly speaking not a ProjectRio kernel that's running. It's actually Tiny Basic Computers for color, which is a version that you can get on the ProjectRio Patreon. I appreciate that's a little confusing as a statement, but just trust me on this. This particular build is not currently available, but what you're seeing is running purely off one chip, an ESP32, so it is actually running as a 32-bit version of BASIC, and using the FabGL library, it is running its own video. So it looks similar, but it's not quite the same to the Raspberry Pi build that we had been using previous for our terminal. It does work, although it has some issues like backspace for this doesn't work again. If I go mem, you can see that it actually has a generous just over 32K of RAM available. So as all the builds we have for Tiny Basic ProjectRio computers, this is by far the most generous with RAM. Now, it's all very good, and I believe CLS doesn't work, but could work. I haven't set this up properly, but it would work without needing to pass serial protocol. However, let me show you what the big problem with this build is, and this is an issue relating to FabGL. Okay, so I have just written here a small program basically to take a number and count up. So x equals 0, x equals x plus 1, print x, and then go back to 20 to repeat the process. Simple program, you've seen it many a time here on the channel. Let's run that. Okay, so you can see it's counting up in numbers, and that is something that we would expect to see. So if I now try and break out the program using the escape key, if I hit escape, you can actually see what it does is it actually crashes. And I couldn't figure out why hitting the escape key would make it crash. I had a look at my source code, and I even actually downloaded another build of Tiny Basic for the ESP32 and FabGL. Not as equipped as the one we're playing with, but I thought I'd try it anyway, and it also crashed every time you hit escape. I haven't been able to figure out the issue. It seems to be something primarily to do with the FabGL library. It just doesn't like the escape key being pressed when it is generating the PS2 protocol for the keyboard. There's also a couple of other issues. If we're going to use ESP32, yes, we have the RAM, yes, we have the power, but we don't have any EEPROM unless we add it externally, so there's no way to store programs on chip. You also don't really benefit, other than RAM and processing speed, in functionality over the 8-bit AVR chips. This escape key function keeps breaking if we try and drive the keyboard through the protocol provided by the FabGL library. And we also don't have access to things like sound. That's right, the sound buzzer system doesn't work. It seems to crash with the ESP32 when you try and compile. It only seems to work on the 8-bit AVR architecture. Plus the fact using this kind of board, we lose HDMI compatibility, we lose composite, PAL, analog and NTSC compatibility, and we also lose the ability to drive the keyboard via USB. At least with the Raspberry Pi build, it's possible to drive a PS2 or USB keyboard, giving you much more options. So in all, I was a little bit disappointed with this board. It's not to say this board is in any way useless. It is actually quite good at running a lot of the completely stock FabGL libraries. I just don't think it's quite the path we need to go down. It could be part of the solution, but I'm very much tempted to look at building our own architecture back with the AVR 8-bit chips, as opposed to trying something like this. Okay, so I think we need to kind of think about wrapping this video up now, and I suppose I need to say where I think we actually are with the project and what my next move with Tiny Basic Computers and ProjectRio is. Now, in truth, I don't 100% know, because things change, stuff happens, and new opportunities kind of appear out of nowhere, and it kind of sort of deviates and changes how things work. I mean, when we started this project, I had no idea that it was going to expand out into what it has done, or that it would generate a Facebook group with nearly 200 members now from across the world. What I will share with you, though, is this. So this is a off-the-shelf development board. It's just a single two-sided PCB with a chip area and a breadboard, and I also have this, and this is the Atmega Atmel 1284P, as you can clearly see labelled here on the carry protector. These are 8-bit AVR chips. They are compatible with our source code. They are compatible with the Arduino IDE. Interestingly, as far as I'm aware, they've never actually been used on an Arduino product. They're industrial chips. Very, very popular, though, with retro computer enthusiasts, because they're compatible 8-bit architecture. So it's the same as the Atmega 328Ps that we've been using, or that on the Mega, the 2560. These actually have a very generous 16K of RAM, as well as that 4K EEPROM that we can use with Tiny Basic and ProjectRio. So my thinking is to maybe look at using this development board, getting one of these flash stock to run our kernel, and setting this up to run as a new build for the ProjectRio system. At the moment, although I am still trying other terminal solutions, I'm still thinking of probably sticking with the Raspberry Pi Zero. The Zeros are now more readily available again, which makes life a little bit easier, as are the 1284s that disappeared entirely during the chip shortage, but now have started to appear back on the market at prices that aren't too horrendous. I've seen them around the kind of $15–20 mark. It's a little more expensive, but I think it's worth it considering we can build a whole system reliably and with enough usable RAM on a single IC such as this. Eventually, I'm planning on there being a custom PCB, and instead of myself manufacturing these or getting these made and then again trying to ship them out as kits, although I reserve the right to maybe do that at a later date, I'm thinking this more as a reference design. So one, you would actually tip me some money via Patreon and then download and go and get your own boards made and source your own parts from the list provided. I think that is a much better way of creating a new computing system and architecture and user base that's just different from me trying to make and sell you a product all the time, which is kind of what all the rivals are doing at the moment. So for me over the summer, I think trying to get this prototype built and tested would be a good start. So do look out for future videos for both Tiny Basic Computers and ProjectRio. For those of you that are building your Rio systems to our current specs, don't worry, I have a new video which is on the way soon, and we'll look at how to add the Atari Joystick DB9 interface and how to get that running. I also hope to maybe have some slightly better prototypes of the RioS graphical user interface available to the Patreon backers, so you can have a download and a play with that yourself on your systems that you're currently building. So that just about concludes this update on the ProjectRio Tiny Basic Computers project. If you are brand new around here and haven't done so already, please do consider liking and subscribing to the channel. Thank you as always so much for your continued support and company, and I hope to see you real soon right here on the channel. Until next time, bye for now.